The engineer is not trying to make one part impressive. The engineer is trying to make many small decisions agree with each other. The risk is that a beam can be invisible and still carry enough energy to damage equipment or create radiation hazards. Good engineering does not pretend that risk disappears. It gives the system margins, feedback, inspection points, and simple habits that let people notice trouble early. When those layers line up, the result feels almost invisible. That is the quiet compliment infrastructure earns when it works. This is why particle accelerators rewards patient attention. A design can be technically correct and still fail if it ignores how people move, wait, carry things, make mistakes, or rush. The best version of the system respects both physics and behavior. It gives force a path, gives people a cue, and gives operators a way to keep improving after the ribbon cutting is over. As you watch the footage, look for the small alignment choices, where motion begins, where people pause, where material changes direction, and where the system leaves room for correction. Beam focusing. A useful beam is not just fast. It must be narrow, stable, aligned, and predictable at the target. Beam focusing. A useful beam is not just fast. It must be narrow, stable, aligned, and predictable at the target. In accelerator engineering, the visible object is only the surface of the system. Under it are choices about beam energy, beam current, emittance, vacuum pressure, magnet field strength, RF phase, bunch timing, target heating, radiation dose, alignment tolerance, cooling capacity, detector response, interlock status, and maintenance intervals. Those choices are not decorative. They decide whether particle accelerators feels calm, predictable, and useful when real people use it under pressure. One useful way to understand this chapter is to picture quadrupole magnets focusing a beam the way lenses focus light, except the lens is magnetic field geometry. That moment looks ordinary, but it is carrying timing, geometry, materials, controls, maintenance, and human expectation. The engineer is not trying to make one part impressive. The engineer is trying to make many small decisions agree with each other. The risk